Welcome to a new test and teardown video. This time it's an Oltronix from Sweden Power Supply C15-2D. This is of course a linear power supply from about 1970. I found a schematic, and the schematic was dated 1968. But everywhere I look, it seems like the power supply is from 1970. It's a low voltage power supply. We got the meter, can be either 0 to 20 volts or amps 0 to 4 amp. You need to do a little bit of calculations here. 0 to 4 is 1 amp per line here, right? Very, very complicated math to do there. And then your voltage range can be either 7 volts or 15 volts. And also the current, maximum current is a little bit different. And then of course, line on off, right? The potentiometers, oh, this one is good. Ugh, quite stuck, so I need to do a little bit of cleanup. Serial number is also silk screened on the front. Really? I spent a long time cleaning this and polishing this and making it nice and beautiful for the video. And also here on the top, nice and shiny. It was just full of old dirt and goodies. I better open and inspect a little bit before I just plug it in. This is classic Oltronix, this design with the aluminium profiles making up most of the case. And it's quite heavy, but also very nice and compact. I really like the way that it's standing tall, so it's not using so much space on your desktop. And there's only, I think, yes, exactly, only one screw here at the bottom, so it's just pull this out. Easy, easy. The first thing I see here, look at that. This looks like some sort of a leakage, right? And it's this wire. So something leaked and slimed down that wire. Ooh, yeah, look at that. This is some slimy, nasty, sticky. And where exactly is this coming from? Can I figure that out? Because it's nowhere else. That is interesting. Oh, it seems to be following that wire all the way. Also here, here's that wire. So this is the chemical composition of exactly that wire brand. It is just, see, only that green wire is this slimy, sticky. No other wires got that problem, but only green, and only green in that thickness. How about that? It is a very, very beautiful power supply, and no surprise, this is definitely Oltronix. And here's the main regulator. Electronics, I mean, the whole power supply is just this tiny little board with a little bit of transistors, so quite a heavy packed, oh, lovely, lovely design. They're even using, the small resistors as well. I think we got a little bit of trimmers. That's probably the meters and the sense resistors for current, the different current ranges. And yeah, all the capacitors, of course, they want to put the capacitors near the output. And then the transistor transistors, they're down here at the heatsink. The rectifier here is at the heatsink. Really good thermal design. Again, they know what they're doing. And even the transformer is a slim version, slim but long special version. How lovely is that? We got the extra board over here with all the trimmers, and that is the current mode board. And that meter is also really, really beautiful. But how do I go and clean the potentiometers? And there's one little thing that bothers me about the meter, and that is this little white we see here. I think there's some sort of dirty or pollution inside the meter, so maybe I need to see if I can easily take it out and open it, because they kind of open quite easy if you can just take it out. So I think I'll see. Oh, it looks like it's working, but no leak capacitors. So far so good. This is actually a little bit interesting. So I pulled this little board out, but look at that connector. Half of the pins, they're gold plated, and the other half, they're not. So the gold side goes towards the side of the board that is also gold plated. Good idea. Nice and stable contacts. I just need to clean a little bit down here. We can see it's not super clean. But isn't it funny to see half of it not gold plated? I can't remember if I have ever seen anything like this before. Really, really service friendly, this design. So I decided to take everything out just to clean up this glass that is, you can probably see it here in the, it's really white and annoying, so I really hope that I can clean this. I only need to desolder those two wires. Oh, and there's no good idea in unscrewing this, because then, you see, then you're gonna have this little nut flying around in here, so that is not the way. I think I found the reason for all this white dirt or dust to go inside. See, there's supposed to be a sticker hiding this big hole, and that one is missing. I think I found it inside this unit. And also all those extra holes you see here, and I mean, it's supposed to be completely sealed. Let's try to do a little before and after here. This is not looking nice, is it? I definitely think I can get all this. That is weird. It's still inside the plastic. Really? It is there, like permanent damage. Well. At least I get some of it away. I'm not happy about that. There's something infected this plastic. What do you think about that? I think it's impossible to show how nice and clean it is. Maybe if I hold something here at the back. So what I was doing is I put in some toothpaste in these cotton buds and then wiped a lot back and forward, and then I could get this annoying stuff away. It wasn't really going away with water or alcohol or anything like that, but toothpaste, that was definitely the trick. Oh, by the way, I also realized another little problem. Look at that. And that one here. So that will be the little marks from the 2 screws going through the 2 knots right there. So the 2 screws from the side here and here, they're a little bit too long. So this is a design problem. Really? Why did they do that? Cracked the meter completely. Yeah. So I am in the assembly process of everything here, and I realized something on the meter. If you look under the black 0, can you see a tiny little 0 there? Maybe it was supposed to be a red 0. Under number 5 is a invisible 1. Under the 10 there is a little number 2. Oh, damn it. Is that possible to see? And a 3 under number 15 here. And there's a little red 4. So the thing is, when you push this button right there, the meter, you go 0 to 4 amps in red. Very user-friendly, nice readout idea. The problem is sunlight destroyed the numbers in here. This is a classic thing with the red. Cannot handle sunlight. So let's try and test this thing. Ooh, there's a loud hum from their transformer, I guess. Let's see. Here's the voltage. Oh, it's responding real good. So we are in the 7 volt range. I really like the idea with the little indication here. So let's change the and then fine. What's going on? See, there's a problem. Oh, that's weird. So if I in both ranges? Yeah, oh no. See? Aha, so that switch is not. No, this capacitor gets discharged. So we got some diodes that is not working in the rectifier bridge, or some transformer windings that is not working. That is interesting. Current limit. Well. And there you have it. Yes. And then it goes all the way down. Of course it's not working. So to understand the basic behavior of this power supply, I found the schematic, and here we look at the whole schematic. We can see the different circuit boards. In the top middle, we see the main power supply regulator controller board, and in the top right we see the trimmer adjustments alignment board. This is also the one that's doing current limits. And in the lower left we see the voltage range selection system, and this is where we have our problem. So maybe we should try and zoom in a little bit on the voltage select system. We see the switch 2A that is switching between some windings in the 2 different voltage ranges, and I will try to highlight the different behavior. So here is a 7 volt mode, and we now see that we are using only 2 of the diodes in the rectifier bridge. And also, in this case, we will get the same voltage depending on, let's just pretend half of the switches are not working, or this top winding is not working, and it will still work. Only one of the windings will make the voltage. So all these things I will have to investigate a little bit here. Let's look at the 15 volt mode. Then the switches, they're connected something like this. And now we see both of the 12 volt windings, they are now in series. And then the rectifier bridge is now in full bridge mode. And then I believe this is the mode that is not working. So that tells me a little bit about which one of the switches I need to look at. Maybe it's some of the wires or something like that. It could also be the bridge where we have the fault, of course. So this is the voltage range switch, and it's doing all the different tapping and funny stuff with the transformer windings and the rectifier and all that kind of stuff. And if we look a little bit, yeah, we got, what is that, 6 sections on those switches. That is wild, but only 2 of them here on the bottom left, they are used for this voltage selector stuff. We also use one just to handle the little lamp indicators right there. So anyway, those wires there, I just follow the wires. I had to remove all the little, tie everything up, and here's the rectifier, and it's quite easy to see. That is the gray one, and I loosened everything here so we can see where that one is going. And here's the red one that goes to the capacitors. And when I push this in, remember, this is when the voltage was lost. And the red one goes to the capacitors, and there is no connections between the gray and the red when you push this in, but you're supposed to have that. You can even see it's a little bit brown and blown up here. So that is the problem with this switch. So I can follow all the wires here to the transformer, and it's quite easy to understand what is what here. You can see this green and yellow, that is the 12 volt winding, and here we got 6 and 6 on those 3 wires right here. So anyway, I added all the different colors right here, and what I want to do is I should put in a schematic right here so you can see my idea is much more simple, and it is exactly the same that happens, the same number of windings, the same number of volts and all that kind of stuff, but I only need one switch, and for that case I can parallel 2 of the switches instead of using them in series. And what I want to do is, I feel there is one extra section up here behind those wires. We can't really see it up there, but there's probably one extra section, and that will be one of the 2 parallel sections I want to use. But first I want to clean up all this and remove everything here and yeah, do it nice. So here we go. I rearranged everything. I moved some of the other wires, and now I got 2 sections for my voltage selection. It's a much more simple approach, and it's also a little bit easier with the wires here. I got less wires to worry about, and I think we should just test this and see if it yeah, works. One other little detail to mention, the switches, they were mounted here using ultra short screws, so that was the screws for the other side using different screws, and that is why somebody took everything apart and put in the wrong screws, and this way damaged the meter. So if only they used the shortest screws that actually also works over here, then they wouldn't have this possibility of error. Very, very important lesson to learn. Use as little as possible different screws. So here we go. And I should be able to crank up the voltage. So this is the maximum output voltage in one mode. It's 18. And then it goes down a little bit in the other mode. We should probably put on some load to see a big difference here. So what are we doing here? This is 1 amp, and then it drops to 14. And here's 18. So it's supposed to be doing only 7 volts for full specifications here. So it's also unregulated, so you probably get a lot of ripple, as you see here. So this is the ripple output in the wrong range, and then we go the other range. We got plenty of voltage to regulate, and then we have no ripple. So all that seems to be working. Let's go over here and crank down the voltage a little bit until we see no more ripple. So that is probably about 10 volts, so there's a little bit of margin. Yeah. All right, so it is back, solved the problem. Let's see the meter. How accurate is that? So this is 1 amp, and it is about here. It's because of the angle. So I believe, yes, if I go down here, it is probably working more or less. So that is a 1 amp. Let's try and give it 2 amps like that. And then it goes to, yeah, I should probably trim it a little bit. It should be fairly easy to do with this trimmer board. I will just assemble everything, and then we are perfectly done and super happy again. Wow! So, I think we did it. And that is the end of this video. So thank you very much for watching. I hope you had a little bit of fun. At least I was definitely entertained. It was a little bit of a challenge with all the different mechanical things and switches and whatnot, but it is a beautiful power supply, and I really love those Oltronix, so it was definitely worth all this work. So yeah, bye for now.